Right, so this one involves us using trigonometry, except it's in a slightly different context. It's not immediately obvious. So we can see that there's a right angled triangle because this is our horizontal ground, and we really hope that the lighthouse is completely vertical. So that should mean that there's an angle of 90 degrees in here. And then we've got two positions, A and B. Okay, so I'm going to decide that this one is going to be position A, and I'm going to draw on position B much further down here. And remembering that the angle of elevation is when we're looking up, so if we're at B, there's my horizontal and I'm looking up with an angle of elevation of 14 degrees. So there's 14, and the angle of elevation from A is 30. Okay, I know I've got them the right way round as well because I can see that this is a bigger angle than the 14. So essentially I'm going to do trigonometry twice. First of all, to find the distance from the bottom of the lighthouse to A. So that's this distance from here to here, using that triangle that was drawn for us. And then I'm going to repeat it for my second triangle to find the distance of the lighthouse from B. And then as I've got to find the distance between A and B, I can just subtract those two distances from each other. So first up, I'm going to draw just one triangle for A. So here's my lighthouse, here's my 30, and here's my A and my right angle. And just having one triangle and then doing the B separately will just help me to separate out the two things that I'm trying to achieve. But in both cases, I'm looking for that distance. But I'll give it a different letter for that because it's obviously going to be a different length. So I have my hypotenuse in both triangles, I have my opposite in both triangles, and my adjacent in both triangles. I'm also told that the lighthouse is 52 metres high, so I'm going to write that on my diagrams. So I'm looking at what I'm trying to find, in both cases the adjacent, and I'm given the opposite. So out of SOHCAHTOA, this time it's the tan formula triangle. So tan theta is the opposite over the adjacent, and as we're finding the adjacent, we'll cover the adjacent up and we have to do the opposite divided by tan of the angle. So for my first triangle, I'm going to get that x is the opposite, 52, divided by tan of the angle, which is 30. But in the other one, I'm going to get that y is 52 over tan 14. So here I get an answer of 90.06, and for the other I get an answer of 208.56. So now my final step, if I just move everything up slightly so we have a bit more space, I'm just going to look at the distance between the two. So distance between A and B is going to be 208.56 subtract 90.06, and that's going to give me 118.5 metres.